Alright, welcome back. In the last video, we were talking about extrapolation, misusing regression, and then the sort of checklist here. Now, one thing I do want to talk about is how hypothesis tests are used in regression, and it's pretty wild. It's pretty cool. It's the same process as what we were doing with t-tests by hand, except it's a little bit more involved mathematically. You don't have to worry about that, which is wonderful. But we have essentially two tests that are going on, one for the slope and one for the intercept. And we'll start actually here with the intercept first, because its null and alternative hypothesis are pretty more or less kind of easy to understand. The null hypothesis here is that the beta naught cannot be trusted. That's sort of the conclusion there. So if your p-value is greater than 0.05, right, then you go with the null. If it's less, then you go with the alternative, right? And so just kind of keeping things simple and easy and translated in English, this is what's going on, right? So if your p-value for your intercept in your model, and we'll write this down, so we'll keep writing this. So we know if our p-value for this value here is below 0.05, then we can trust that this value is close to reality, okay? If it's not, then we cannot trust that this value is close to reality. If the p-value for just the intercept is over 0.05, we can't trust this, okay? Now with the slope, there's a little bit we have to do. And by that I mean plug in a 0 here, and that's it, right? So what this is saying, and I'll kind of draw it over here. I think I drew it earlier too. Where if we have a slope of 0, right, and you should remember this hopefully from your last math class, whatever it was. If you have a slope of 0, that means that your line looks like this. There is no slope, right? And we get from the slope, from this beta 1 here, we get our, sort of our effect of x on y from that value, okay? So if the slope here is 0, then that means there is no relationship between x and y, essentially, okay? And that we cannot trust the value that gets spat out here, right? If our p-value, though, is below 0.05, then we'll say that it's not 0, and it's going to be something else, right? So slope of not 0 can look like this. It can look like, and I'm just saying not 0, it can look like this. It can even look like that, where it's very subtle, but it's not totally flat, okay? So that's what we're doing here. That is what we're doing here. Now, what can we do? What can we do with this equation? Okay, well, why don't we just come over here first? I'm going to draw two things. So the first thing I'm actually going to do is our p-value for our intercept. Let's say that the p-value for the intercept is greater than 0.05. Okay, so we cannot trust it. We'll assume that the slope is legit. Okay, so we'll say that this is for the intercept. And then the p-value for the slope. We'll say that the p-value for the slope is under 0.05. Okay, so that's all fine. That's all good. What does this look like if we were to draw this? Well, what this looks like, so we've got two things, and I'll draw you essentially what's happening. This is not what actually is happening, but how we can interpret this, right? Okay, so we have some data. We'll try to actually, you know what? Check this out. Watch this. Watch this. This is crazy. Copy. Whoa. Cool. Okay, so here's what's happening, right? We have our data and whatever, and let's say that we're only focused on the intercept right now, okay? And we know that, just based on this example, the p-value for the intercept is greater than 0.05. So we cannot trust that the value for the intercept is actually the true value, okay? So what we would draw here, I'll draw with this green color. If our intercept can't be trusted, then essentially what's happening is we're saying, okay, well, the line either looks like this, right? It can look like this. It can look like, I'll draw another one. It can look like this, or it can look like this, right? What do we notice? What do we notice? Well, we are not really able to say much about where the line actually intersects the y-axis here. Oops. Where it actually intersects the y-axis, okay? But since our p-value for our slope was statistically significant, that is unchanging, right? So the actual relationship between these two values, I tried to artistically show it as best as I could. They're the same. It's always the same, okay? Where we are able to trust the slope. So the slope is unchanging here. It's just the location of the line that is changing. So if I were to then say, okay, what if I plugged in a new x value? What if I plugged in, say, right here, and I want to predict a new y value? Can I? I cannot. Because based on this line, since all of these lines represent the same model, okay? But since we can't trust the intercept, well, if I were to plug in some x value and try to get a new y value out of it, it's either going to say it's here, it's either going to say it's here, right? We're just not able to say much about the predictive accuracy of our model. We still can say a lot about the slope. Okay, we can still say a lot about the slope and the relationship between those two things. But as far as it comes to predicting, we are just we're out of the park, right? We can't even get in. We cannot predict if our p-value for our intercept is greater than 0.05. So what I'm going to do, I'm going to erase all of this. Erase all of this. Fast forward if you want. Great. Okay, and let's write this out. So if, do I have this on the last? No, I don't. Perfect. If the p-value is let's say greater than 0.05, but slope is less than 0.05. The p-value, if the p-value for the intercept is greater than 0.05, but the slope is less than 0.05, then what can we do? Well, we can only use, and this is going way back to the first or second slide, we can only use equation for relation between x and y. Okay, and that's it. Okay, that is it. And then if we say the same, slightly change it, if the p-value for intercept and the slope are less than 0.05, what can we do? Well, we can do relation and prediction. Okay, so prediction here is plugging in some x value and figuring out a y value. Relation is only looking at the slope, is only looking at that relationship, right? That for every 1 unit increase kind of situation, okay? Now, what about the slope? What about the p-value? And can we trust the value, the actual estimate for the slope, if it's greater than 0.05? What do we do? Okay. Well, I'll draw this, right? So we'll say that the p-value is less than 0.05 for the intercept, we'll say, but then greater than 0.05 for the slope. What does that look like? Well, it's going to be very similar to what we saw before, except, so what we're saying here is that we can trust our intercept, but we cannot trust the slope. So we get some data, right? No biggie. I messed up. I should have done that magic again. So we'll just say it's the same data, right? What we're saying here is that if we can trust the intercept, well, then it's going to be like right here, we'll say. But if we can't trust the slope, well, either the regression equation, the line would look like this, or like this, or like this, where it's all in the same spot, right? Or like this, essentially 0, or like that, right? It can be any of these things. We just cannot trust the actual relationship component or the predictive component, right? Because all of these, this is going to be wrong in every sense, right? If I plug in some x value here, well, based on any of these lines, they're all going to be wildly off. And the slope is always changing too. So the definition of the relationship is just not going to be there either, right? Okay, so that's essentially what's happening. So let me do this. Let me do this. Yeah, wow, so much faster. If the p-value for the slope is less than 0.0, no, is greater than, you cannot do anything. Go home. Go home. You can't predict or relate, right? Because the big thing in regression is you want to check the slope, right? That's always the big thing. At least, can you make a relationship? Can you define the relationship between x and y, right? And you look at the p-value for the slope. And then, if just by chance, it is always nice if you can use the regression model for predicting too. And then you would look at the p-value for the intercept. And then you would look at the residuals to make sure that you're not over or underestimating in a specific spot. So that's essentially what's happening. Okay. So what I'm going to do next, I'm going to show you some examples because I think that's the easiest thing. If you haven't caught on by now, 7 weeks later. Okay, cool. So I'll see you there in just a little bit.